Hi guys and welcome back to Maths with Kat. So today we are going to be going over geometry of lines and circles for AQA A-Level Maths. So the first thing we need to go over is formatting equations of lines. And what this means is there are different ways to write the equation of the lines. So we're going to go over different ways. So the first one is this: y minus y1 equals m lots of x minus x1. Second one is y equals mx plus c, which you'll have seen at GCSE. And the last one is ax plus by plus c equals 0, which is kind of just a rearrangement of y equals mx plus c. So is this actually. So this one can be used to get y equals mx plus c, and this one. Y1 and x1 are coordinates on the line. M is the gradient, and C is the y-intercept. A and B are just coefficients for the x and y in the equation. So we'll go over this first one in more detail. x1, y1 is a point on the line. M is the gradient of the line. So here's some examples. Find the equation of the line that passes through the points -3, 10 and 1, 4 in the form y minus y1 equals m lots of x minus x1. So the gradient m is equal to y2 minus y1 over x2 minus x1. Changing y over changing x. We have two y values and two x values, so we'll use these. So 4 minus 10 over 1 minus 3. That's going to be the gradient. And that's the same as minus 6 over 4, which can be simplified to minus 3 over 2. Then we're going to choose one of the sets of coordinates as our y1 and x1. So we'll go for this one. So y minus 10 is equal to minus 3 over 2 lots of x minus 3. That can be rearranged to give y minus 10 is equal to minus 3 over 2 lots of x plus 3. That is in the form asked for. That asks us to express the same line in the form y equals mx plus c and ax plus by plus c equals 0. So y minus 10 is equal to minus 3 over 2x minus 9 over 2. All I've done there is expand the brackets on the right hand side. Then that can be rearranged by adding 10 to both sides to give y equals minus 3 over 2x plus 11 over 2. That is in the form y equals mx plus c. So for the next bit, we want it in this form, ax plus by plus c equals 0. So first thing you do, move it all to one side, so you end up with 3 over 2x plus y minus 11 over 2 equals 0. The only reason I've done it in this order is because that's the order it gives in the question. Then what we can do is we can times up by 2 to get all integer values. So 3x plus 2y minus 11 equals 0. And that is in the form ax plus by plus c equals 0. Midpoints of line segments. So coordinates of the midpoint of a line segment, AB, can be found using a simple equation. Midpoint AB is equal to XA plus XB over 2, YA plus YB over 2. So they're the coordinates. So here's an example. Find the midpoint of the line segment between 4, 3 and minus 2, 5. So the midpoint coordinates are going to be 4 plus minus 2 over 2 and 3 plus 5 over 2. 4 plus minus 2 over 2 is 2 over 2. 3 plus 5 over 2 is 8 over 2. Both of those can be simplified to give 1, 4. Length of line segments. The length of a line segment, AB, can be found using Pythagoras' theorem. You'll remember Pythagoras from GCSE, but you'd have known it's slightly different from this. So if you can imagine, if you've got a line, in fact, I'll do a little drawing to make this easier. So this is our line. It's supposed to be straight, it isn't. And this length here is the change of y, and this length here is the change in x. So the change between these 2 points for the x value squared is this side, which we can label A. And the change in the y coordinates, so change between here and here, is the length of this side, which can be B. And this is the hypotenuse, which is C. So the length of this is equal to A squared plus B squared. That is equal to C squared from Pythagoras. And we know from what I talked about before that A is the change in x, that is the length of that, and that B is the change of y, that is the length of that. So that's why you get this. So here's an example. Find the exact length of the segment of the line with equation y equals 5x minus 2 between x equals 3 and x equals 4. So when x equals 3, y is going to be equal to 5 lots of 3 minus 2, which is 15 minus 2, which is 13. And when x equals 4, y is going to be equal to 5 lots of 4 minus 2, which is 20 minus 2, which is 18. So let's sub them into this equation. The length is going to be equal to square root of 4 minus 3 squared plus 18 minus 13 squared, which is the same as the square root of 1 squared plus 5 squared, which is the same as the square root of 1 plus 25, which is the same as the square root of 26. Parallel lines. So this slide is going to go over some of the rules of parallel lines. They always have the same gradient and they never intersect each other. Here's an example. The equation of L1 can be written as y equals 3/4 x minus 7 over 4, which is the same as 3x minus 4y minus 7 equals 0. Find the line parallel to L1 that passes through the point 3 minus 1. So, because they are going to be parallel, they're going to have the same gradient. We can now use the equation y minus y1 equals m lots of x minus x1 to find the equation of the second line, because we have coordinates. So y minus 1 is going to be equal to 3/4 of x minus 3, which is the same as y plus 1 being equal to 3/4 x minus 9 over 4. And then if you minus 1 on both sides, you get y is equal to 3/4 x minus 13 over 4. So it's that simple. Parallel lines, real easy. Just got to remember, same gradient and go from there. Perpendicular lines. My laptop's being a bit slow, probably because it's on charge. So we're just going to wait for this. But perpendicular lines meet at a 90-degree angle to each other. So the gradients will multiply to make minus 1. This means you can work out the gradient of a line perpendicular to one you already know the gradient of by doing minus 1 divided by known gradient. Now, I personally, just in my head, will switch the denominator and the numerator and then put a minus in front. It does the same thing. So the equation of the line L2 can be written as y equals 1/3 x minus 1, which is the same as x minus 3y minus 3 equals 0. Find the line perpendicular to L2 that passes through the point minus 2, 4. So L2 has gradient 1/3, as you can see from the equation. As the line we are looking for is perpendicular to this one, it has a gradient of minus 1 divided by 1/3, which is the same as minus 3. We can now use this equation again to find the equation of the line because we have coordinates. So y minus 4 is equal to minus 3 lots of x minus minus 2, which is the same as y minus 4 equals minus 3x minus 6, which can be rearranged to give y equals minus 3x minus 2. This is something a bit different now, the equation of a circle. So the equation of a circle, centre AB, radius r, is x minus a all squared plus y minus b all squared equals r squared. You'll recall from GCSE, you only did them centred at the origin. So you'll just had x squared plus y squared equals r squared. And if you think about it, if you sub in 0 for both A and B, that's what you get. Here's some examples. Find the centre and radius of a circle with equation x minus 2 all squared plus y plus 3 squared equals 16. So it's centre 2 minus 3 and radius 4. Now, the way to remember this is most of the time if you've got brackets in an equation, any numbers inside the brackets, you switch them to get coordinates of whatever you're trying to find. So for the centre here, you switch the sign, and then for radius, just remember square root. Write down the equation of the circle with the centre minus 4, 2 and radius 6. So this will be x minus 4 all squared plus y minus 2 all squared equals 6 squared, which is the same as x plus 4 squared plus y minus 2 squared equals 36. Write the equation x squared plus y squared minus 6x plus 4y plus 4 equals 0 in the form x minus a squared plus y minus b squared equals r squared. So I rushed through the last two because they're quite simple. This one is slightly more complicated. So, firstly, put the x terms and the y terms together, and then put any numbers to the other side, like this. Then we're going to kind of complete the square. So, as we've completed the square, half the number before the x value. So that was a minus 6. So we're going to write x minus 3 and square it. We don't have any number value here. So we want that to be 0. So we're going to minus 9 afterwards, because minus 3 times minus 3 would give us a plus 9 on the end, and we don't want that. Do the same for the y. So y plus 2 all squared is going to give us y squared plus 4y plus 4. We don't want a 4 afterwards, because there's no plus 4 here. So we're going to minus 4. And that is equal to minus 4 from when we moved the 4 to the other side at the beginning. Then if we move them two numbers to the other side, we then get x minus 3 squared plus y plus 2 squared equals 9, which is in the form it wants. So this will be a circle, centre 3 minus 2, radius 3. Properties of circles. So you might know these as circle theorem. These are the main ones that you'll need to know for A-level. The angle in a semicircle is a right angle. So you can see there's a semicircle here. If you take points from the edge of the diameter up to the edge of the circle somewhere, they will meet at a right angle. The perpendicular from the centre to a chord bisects the chord. So any line that goes from the centre to a chord, which is just a line that goes across the circle, will meet at 90 degrees. And a radius and tangent to the same point will meet at right angles. So, again, basically any point from the centre to the edge of the circle will meet a tangent to the circle, so a line that only touches the circle at one point, at 90 degrees. There are things you just kind of have to remember. You'll get used to the idea of using them. The gradient rule for perpendicular lines. So it's easier to just go straight in with an example for this one. So point A at 6, 4 lies on a circle with equation x minus 2 squared plus y minus 1 squared equals 25. Find the equation of the tangent to the circle at A. So the equation of the radius at A, so from the centre to A, has a gradient m equals 4 minus 1 over 6 minus 2, which is 3/4. How is this useful? Well, on the last slide, we learnt that the radius would meet a tangent at 90 degrees, and we're looking for the tangent at that point. So, as you can probably remember from before when we went over perpendicular lines, they are at 90 degrees to each other. So all we have to do is flip. Oh yeah, sorry, I've skipped a line here. So all we have to do is flip and make a minus, or do -1 divided by the gradient of the radius, and you get -4/3. That is the gradient of the tangent. So the equation of the tangent we can now work out because we have a point on that. Y minus 4 is equal to -4/3 lots of x minus 6, which is y minus 4 equals -4/3 x plus 8, which can be then rearranged to get y equals -4/3 x plus 12. So that's the end of this video. I hope you found it useful. If you could leave any feedback in the comments, that would be great. Comment, share, like, subscribe, and I will see you in a future video, hopefully. Bye bye!